So number 27, we have a spring versus position graph. We pull the block back out to 12 centimeters and release it. How much work does the spring do on the block when the block moves from positive 8 centimeters to 5 to -5 to -8 and -10 centimeters? Well, this 12 centimeter that they mentioned here really does not apply at all. Instead, we just have this graph of it being stretched to -2 to +2 centimeters. But based on that, we can actually figure out the spring constant. If we go ahead and use this point right back here, the force is, oops, sorry. Actually, we're going to use this point here. The force is -160 when the position is +2 centimeters. Plugging that in, we can find the spring constant 8,000 newtons per meter, or newton meters. We can then use that to figure out this next part. Work we know is equal to the negative change in potential energy. So in this case, that would just be the negative of the final potential energy minus the initial potential energy. Because we're taking the negative of that, we can just reverse the signs, initial minus final. So for the first one, the initial, we're starting out at 8, and we're going to +5 centimeters. And if we subtract that, we'll get 15.6 joules. The second one, we're starting out again at 8. This time we're going to -5. The fact that it's going to -5 does not change our answer at all because of the squared term. It's going to be still 15.6. See, we go from -8 to +8 to -8. The total amount of work done is 0, and that might bother you, but please realize basically you're finding the area underneath this curve here to figure out the work. And in this case, the positive and negative work are equal to each other. It cancels out. And then finally, D to -10 centimeters, the work here actually becomes negative. It does more work, or does more negative work than positive work. Hopefully that makes some sense. Good luck with this one.